Hello and welcome to our lesson for today. Since I'm gone, I'm going to just record this so you guys can kind of see the notes for it. Now, first off, what we're going to do here is we're going to start this new chapter, and the new chapter is on solving linear systems by graphing. So, first off, what a system of equations is, it is two or more equations of the form ax plus by equals c or dx plus ey equals f, meaning you basically just have two linear equations. We've been working with these for the past chapter, and they can be written in standard form. They can also be written in slope-intercept form as well. So one of those two forms there. And what we're going to be looking for is we're going to be looking for the solution to the system of equations. And what the solution is, it's the ordered pair of x comma y that satisfies each equation. Now, to get started, we're going to talk about the different types of solutions. Now, there's three possible solutions that we have. The first one is having one solution, and what that means there, if we're having one solution, is we graph out our two lines. So there's our coordinate plane. We graph out our first line, we graph out our second line, and these two lines meet at exactly one point. That point, whatever it happens to be, would be our solution. So that's if we have one solution. Now, it is also possible to have no solutions. What happens there is, obviously, if you have one solution, you meet at one point. So if you have no solutions, you're not going to meet at any points. So if you graph out your two lines, there's line number one. We'll draw line number two down here. And these two lines are, from geometry, you should know this, they are going to be parallel lines. So if the lines happen to be parallel to one another, that means you're going to have no solutions to this system. And remember, just from last chapter as well, you get parallel lines if the slopes are the exact same. So you can kind of double check your slopes to make sure with this. Now, the other possibility is an infinite number of solutions, and what that means is there are so many solution points that you can't even count them. So what we're going to do to look at this here is we'll draw out our graph. There's our first line right here. And then when we draw out our second line, that second line is actually the exact same line. So as you kind of draw it, the line is actually on top of each other. And if you kind of look at it, there's a solution point, there's a solution point, there's one, there's another one, and so on and so on. And since they keep going forever and ever, there's actually an infinite number of them out there. So those are our three different possibilities for solutions. When we look at examples, that's what's going to happen is one of those three things. We're going to have one solution, and we'll actually want to know what that ordered pair is, that x comma y. There's no solutions to it. When you graphed it out, you just saw parallel lines. The third possibility would be, like we just saw, an infinite number of solutions. And you obviously can't say the ordered pair that's the solution because there's so many of them. All right, first example. What we're going to do is we're going to solve this system of equations. And in order to do so, we're going to solve it out by graphing. Now, when you guys do your assignments, what I want you using is you need to use graph paper and you need to use a ruler. Just by doing that there, that'll help you to get your solutions as accurate as possible. Because this graphing is just really an estimation of it. You're going to learn tomorrow how to actually find them algebraically. All right, so to graph these, I'm actually going to graph this bottom equation first here. And the reason I am is because that one is in standard form. It's really easy to use the cover-up method in finding your x and y intercepts. So by doing the cover-up method, you should know that your x-intercept right here is going to be positive 3. The y-intercept is also going to be positive 3. So what you can do then is just kind of draw your line there. All right, so we'll draw this line that goes right through these points there. And it's kind of hard for me to draw it perfectly straight on here, so that's why I suggest you guys using a ruler when you do it. Alright, so there's the graph for that line. Now the second, or that first equation that's up there, 2x minus 3y equals 1. If you think about cover-up method, x-intercept 1/2, y-intercept negative 1/3, that's actually kind of hard to see the graph for it there. So what I'm going to do is I'm going to rewrite that one in slope-intercept form. So first step, just subtract that 2x over, negative 3y equals negative 2x plus 1, and then divide over your negative 3, so y is equal to positive 2/3 x minus 1/3. And it might be easier to graph it in that sense. The reason for that is we're dealing with less fractions, and so it might be easier in that sense. The other way you can do is you can just plug in points too, and you should kind of be able to see solutions as you plug in points. So, alright, anyways, negative 1/3 our y-intercept, we'll put that about right there. We have our pen that we're doing, so right there is negative 1/3. Then what we're going to do is we're going to rise our 2 units and then run the 3 over there. So that will be about where that next point ends up. So we kind of draw our line right there. We draw this right here, and you can kind of see that we meet at one solution point. That solution point actually happens to be the point 2, 1, which would be our solution to that system of equations. So in this particular example right here, what we want to see is the solution to it, and it is the point 2, not negative 1, 2, positive 1 there. So that would be our solution. If you want to check it, you can always plug the numbers in there. 2 plus 1 is equal to 3 in that second equation. Top equation, 2 times 2 is 4, minus 3 is equal to 1. So that would be our exact solution. Now, since we're just doing estimates, if it happens to be a fraction, that's fine in this case there. But the graph paper and the ruler should help it be as exact as possible. All right, second example I want you to see is this one right here. Now, graphing them out, they're both in standard form, so we'll kind of just graph using our intercepts. First equation, x-intercept is positive 2, and the y-intercept is negative 3. Draw that out right there. Draw our line through those points. There is that line right there. Second line, x-intercept is 2/3, so we'll put that right there. Y-intercept, negative 1. Once again, we'll draw out that line right there. And these lines right here, they happen to be parallel to one another. So as we kind of saw from a couple slides ago, if they are parallel to one another, that means there are no solutions. The graphs do not meet anywhere. So in this case right here, we would have no solutions to this system of equations. So that's kind of in a nutshell, just this first section on solving a linear system by graphing. And since I was gone today, this is just kind of a brief introduction into it. We will get in more detail into it tomorrow. But the rest of this period with your sub, I would like you working on this assignment. It is due tomorrow, and don't forget to use graph paper and a ruler on it to make this as accurate as possible. If you have any questions, I will be in tomorrow before school, so you're welcome to come in and ask then.